The design in automobiles has been safer every new generation of vehicles. And one of those safety additions is the crumple zone, which helps protect us in an accident. Hi, this lesson is on impulse. So change in momentum is such an important concept, it received its own name, which is impulse. So if you see change in momentum in a question or impulse, they both refer to the same thing. So impulse is in newtons per second, force is in newtons, and then time is in seconds. So impulse and change in momentum have the exact same formula, but they have different units. So change in momentum is force multiplied by time, and therefore impulse is also equal to force multiplied by time. So, for an example, if a raw egg drops to the floor exerts a force of 9 newtons over the time interval of 0.03 seconds. Determine the impulse required to change the egg's momentum. So first, you should write down the units that you were given. So you were given force and time and asked to calculate impulse. So writing down the formula for impulse, force equals force multiplied by change in time, 9 newtons times 0.030 seconds gives us a total impulse of 0.27 newtons per second. Impulse is equal to change in momentum, and impulse is equal to force multiplied by time. But change in momentum can also be found by mass multiplied by change in velocity. So that also means that impulse can be found when you take your mass and multiply it by your change in velocity, which can be also expressed as impulse is equal to mass times final velocity, subtract mass times initial velocity. So even if you're not given a force and time, you can still calculate the impulse of a collision by using the mass and velocity. So always start with collecting your variables and then try and figure out which formula will best suit the situation. So a raw egg with a mass of 0.065 kilograms falls to the floor. At the moment the egg strikes the floor, it's traveling at 4.2 meters per second. Assuming the final velocity of the egg is 0 after impact, determine the impulse required to change the momentum of the egg. So collect your variables. We have final and initial velocity, mass, and we're asked to find impulse. So we can use the formula impulse is equal to mass times final velocity, subtract mass times initial velocity. And then we're going to put in our variables, including their units. So 0.065 kilograms times 0 meters per second. Subtract 0.065 kilograms multiplied by 4.2 meters per second. And this gives us an impulse of negative 0.27 newtons per second. So again, we want to talk about the time interval when it comes to forces. So think about throwing a baseball straight up into the air and then catching it in your own hands. If you hold your hands rigid and stiff when the ball hits your hands, it will stop almost instantly, so a small time interval, but it will strike with a greater force, hurting your hand. If you let your hands give when the ball hits your hands, it will stop over a longer period of time, but will strike your hand with a smaller force, so it won't hurt as much. The impulse to stop the baseball in both cases is the same, but by increasing the time period of the change, we decrease the force. So again, if we have a large time, we need a small force to have the same impulse as if we have a short amount of time and a large force. So in the top equation, we have a small force, but a large amount of time. And in the bottom equation, we have a large force, but a short amount of time. So if one of the factors, force or time, is increased, the other factor has to be decreased to keep the same change in momentum. So again, talking about crumple zones, making a car have give or crumple zones can increase the time it takes for the car to stop, and this decreases the force exerted on both the cars and its passengers. It makes your car more damaged in a collision, but it keeps the passengers inside the vehicle more safe. Thanks for joining today. Bye.